So say we have two equations like we have here to the right. What are each of these equations and describe their parts? Are there any limitations to them? And how does the second equation differ? So this top equation is the dose at a point R using a convolution algorithm. It separately considers primary photons and scatter photons and electrons coming from the primary photon. This A value right here is a convolution-based kernel, essentially a dose distribution by scattered photon and electrons set in motion by a primary photon. This T is terma convoluted by the kernel when integrated or convolved over a volume gives dose. So that's this top equation. Now, the limitations here are that it does not correct for electron density. So the second equation, if you note, we have some rows that are inserted in this equation. Now, this is a convolution superposition equation that accounts for electron density. The kernel is calculated using range scaling by electron density of Monte Carlo generated kernels in water. So what we use for our dose algorithms is this bottom equation, this convolution superposition kernel. We'll cover these a little more in a later video, but I think it's important to have seen these equations because that is something they very well may bring up in your exam, and you need to know what they are, what the difference of them are, and what the limitation is. So really short video, but I think something that is kind of hard just to slip in a separate video, but I really wanted to bring this to your attention. That way you could be prepared for it and do your own research if you have further questions and just thoughts and want further details. This really can get messy in terms of math. I mean, just look at the equations, but I think staying somewhat surface level, knowing how they determine dose in our treatment planning systems is important. And then knowing these equations will set you up for success. If you have any questions, comment below. Thank you for watching. Have a great day.